Hello, this is a video that I've put together to show you how you can set up HTTPS on a Kubernetes cluster. Now, I'm not going to show you all the different approaches for doing this. In fact, there are a lot of different strategies, but this is my favored way in all of my professional work. I won't do this video like a training video. I'm not going to explain every step, and I'm not going to sort of go through every tedious part of the process because there are parts that are quite boring. And the first thing I have to say is that if you've come to this video from my training course, then you'll remember that we fiddled things so that you didn't have to bother registering a domain name. We hacked our hosts file to get this fleetman.com, which actually I think is owned by a proper company. We locally hack things to point fleetman.com at the address of the Amazon load balancer that we're using. So the first thing to say is if we're going to set this up properly, if you want to follow along, you will need to have a domain name and it will need to have been registered through the Amazon DNS service, which is called Route 53. Don't do that just for the purposes of following along because it's going to be quite expensive. You know, if you want a .com, you're going to have to pay $12 for a year. The reasons for having to register through Amazon will become clear shortly. I'm going to do a very specific thing for my HTTPS. There are really two main ways that we could do this. You could set up your Ingress controller to so-called terminate the SSL connection. You can get yourself a certificate, which would be issued by a certificate authority, so you would have to pay for that. And you can install it into the Ingress controller itself. And that would mean that all traffic coming from the browser through the load balancer, which would actually be coming through port 443, not port 80, but all the traffic coming through the load balancer would be encrypted, and it would be encrypted as far as the Ingress controller. And then assuming that the domain name in the browser matches, the requested domain name in the browser matches the certificate installed in the Ingress controller, then the traffic will be decrypted. So it's important to recognize that if you're doing things in the if you're doing your termination in the Ingress controller, then the traffic here, when it forwards the traffic to your individual services, this will all be unencrypted. In other words, this will be HTTP here. If you want to do that, then check out the reference manual for details on how to configure this. I haven't done that for a very long time, so I couldn't even tell you how to do that configuration. The reason I'm not going to do that on a project is simply that means I'm going to have to manage this certificate. I'm going to have to remember when that certificate expires to go get a new one. I'll then have to remember to plug it into this controller, and that's just management work that I'd rather not do. So for that reason, I favour shifting things up a level to the level of the load balancer. And we're going to terminate the HTTPS here at the load balancer. So that means there'll be a certificate installed on the load balancer instead, and then the traffic will get forwarded to the rest of the system using regular HTTP. Now, the massive benefit of doing this is one of the features of an Amazon load balancer is that all of that can be managed pretty much automatically by Amazon, and they will handle things such as rotating the certificate when it becomes close to its expiry. The other benefit is you don't have to pay extra for this certificate, assuming you've already registered this domain name through Amazon. So you've got to pay for the domain name, but the certificate kind of comes as a free extra. And it really does make everything so much easier to manage. There is, however, quite a bit of fiddling around that we need to do, so I'll take you through those steps. So I'm picking up really at the point I left things on the course. I've got a Kubernetes cluster running, I've got an Ingress controller which has a load balancer attached to it, and for me it's this one beginning with the letters ADF. I'm now going to go into Route 53 and find one of my domain names that I've registered. So for the demo, I'm going to use this domain name here, chesterwood.io, purely because I used it earlier in the course for a demo on how you can set up domain names. And I think probably this configuration here, it's the two domain names I've got here are currently pointing to an old load balancer, which I probably used on the original course. So I just need to change those. So I've got fleetman.chesterwood.io, which I'm going to change this alias target here and switch it for this one, ADF, and save that change. Then I've got q.chesterwood.io. I'll make the same change there, ADF, and that's done. You can, by the way, I won't do it here, but you could set up a CNAME record actually pointing at that load balancer, and then you just have to use that CNAME. So if you've got 100 domains to manage, then that's a lot easier because you just have to change the CNAME, and then all of the other domains will pick up that change. But I'm not going to bother doing that here. So I should now be able to visit fleetman.chesterwood.io. There's a very good chance that that change won't have propagated yet. I was expecting potentially a non-existent domain error here. If you get a non-existent domain error, then no problem. Go and have a cup of coffee and come back in half an hour or whatever, and eventually the change will propagate. I'm getting some kind of response, and I've realized, of course, I am going to have to go on to my cluster and I'm going to have to change my routing or routing rules. So looking in ingress public.yaml, use any editor you like here. Of course, I need to change these hosts. So it's now fleetman.chesterwood.io for the public one, and for the secured version, by secured here I just mean there's an authentication challenge on here. I haven't done any HTTPS in here, but this is going to be q.chesterwood.io. And then kubectl apply -f and dot to apply those changes. So I'm hoping now that if I refresh here, I should get... Now, one thing to look out for here is if you've already visited the HTTPS version of this domain, and I have because I've been practicing off camera, then you'll find that even if you visit the HTTP version, you'll automatically be redirected to the HTTPS version, even though we've done no configuration to make that happen. And that's because of this relatively new concept of HTTP Strict Transport Security, or HSTS. And this is something that browsers enforce. Any modern browser should do this. And the deal with it is, if you have previously visited a HTTPS address, and then you try later on to visit the HTTP, the plain HTTP version, then automatically, without any intervention from the server, the browser will force you to go to the HTTPS version. And this is a line of defense against certain attacks. It's actually called a HTTPS downgrade attack, which is great, and it's absolutely something you probably want. But the big problem with it is it does make testing quite hard. So you might think, and this did happen to me once, I was configuring a load balancer. I thought I'd set everything up to automatically redirect HTTP to HTTPS, but actually I'd misconfigured it, but it looked like it was working because I could see it working on my browser. I went to bed, and the next morning I had a load of bug reports saying customers were complaining that they were getting certificate errors and so on. So it was very embarrassing. So I would recommend, if you're doing any of this kind of work, when you're testing things out, do things through curl. So if we do a curl on HTTP, what is it called? fleetman.chesterwood.io, you can see that currently this is responding with the website. We can see from the title here, it's an Angular app, so you don't actually see a lot of HTML, but I promise you that is the actual app. Whereas if we were to request the HTTPS version, because we've done no special configuration so far, that's just not working. The job in this video then is really twofold. We need to get this working, and we need to make sure that if you do visit the plain HTTP, you get an automatic redirect to the HTTPS version. So step one then is, as I promised earlier, we can install a certificate into the load balancer itself, and we don't need to see that certificate or touch that certificate. do anything with it at all. And the way you do that is in your AWS account, if you find the service called Certificate Manager, what you can do here under Get Started is you can request a public certificate and click the button here. And then you need to add in any domain names that you want this certificate to be valid for. Well, we can do star.forme.chesterwood.io. If you're following along and you've got this registered, then you just plug in your own domain name there. If you wanted to serve the root domain, then you would have to add that as a separate entry. So for me, that would be chesterwood.io. And then click on Next. Now, the next thing it needs to do is Amazon needs to be sure that you really do own this domain and you're not trying to hijack somebody else's domain. So there's two ways of doing that. And by far the easiest, especially if you've registered that domain with Amazon, is to use DNS validation. Now, what this will do when I click on Review and then click on Confirm and Request is we'll just see this validation status tick through in a minute. In fact, let's drop this link down. It's telling us that the way to validate this is to add the following record to our DNS configuration for that domain. So at this point, if this domain was registered with a different registrar, then I could go away and do that with that registrar. But the great thing is, if you've registered this in Amazon, you can just click on this button here and then click on Create, and it will automatically go and add that to your DNS configuration. And I can do the same with chesterwood.io here. Create record in Route 53. So that's all I need to do, and it's just a case now of waiting for that change to propagate, and once it has, we should see validation status successful. In my experience, it varies as to how long this takes, but if I click on Continue, it's now taking me to this page here, which will give me kind of a running commentary on the status. If I click refresh, yeah, I'm still pending validation. So I'll stop recording now and come back in a few minutes, keep refreshing, and I'll let you know how long that took. Well, I wanted a break, but it actually only took a minute to issue. But I think it might take up to something like half an hour. So the great thing now is once that's issued, if you wanted to, you don't have to follow along here because we're not going to do this manually, but you can take a load balancer and on its listeners tab, you can edit the listeners. For the secure port 443, if I change this to the SSL version, because we're using WebSockets on the course, we're using a level 4 load balancer here. If you're using a level 7 balancer with HTTP, then you just do the same thing with HTTPS. But for me, I need SSL. We now get the option to plug the certificate in here. If I click on Change and then choose a certificate from ACM, and then wonderfully I can pick the certificate from here. Now I'm not going to click Save, I'm going to click Cancel in fact, because I don't want to be doing that manually. Of course, as much as possible, we want all of this to be driven by Kubernetes. So back onto AWS, we need to add in some extra configuration into the service file for the Ingress controller. So this is the service-L4 file that we set up on the training course. And I don't think we've done any work in this file so far. We just used it as it was basically. We just need to add in a few more of these annotations. And the main one is we can plug in the name of that certificate that we just created. And we do that with, and I'm just copying the line above basically, service.beta.kubernetes.io/. And the first value is the AWS-load-balancer-SSL-cert. And for the value, we need the name, going back into the certificate manager, we need that ARN string that we were given here. So plug that in as a string. We then need service.beta.kubernetes.io/, they all start the same, so I should have copied and pasted that really. AWS load balancer, and then it's -backend-protocol, and this is going to be set to the string TCP. Again, that's necessary because I'm using WebSocket. I'll paste the route in. The next property is AWS load balancer SSL ports, which is going to be set to 443. So with that configuration in place, we've got quite a bit more to do, but if I apply that file, I expect to see some pretty serious changes now. Going back to my AWS console, remember I didn't save any of my changes before, so everything's as it was. If I click the refresh button here, we can see the difference now. It's automatically plugged in a reference to that certificate. It's also set the protocol correctly as well. So that's really great. And notice we have never touched this SSL certificate. And by the way, I should have said there's actually no way for you to touch that SSL certificate. It's managed by Amazon. You cannot access it. Could be a bad thing for some people, but for me, that's a great thing. It means I don't have to worry about them. So with that configuration in place, let's have a look at how things have changed. I don't think we're finished yet, but if we do a curl of HTTP : blah blah fleetman.chesterwood.io. That's not good. We're getting back the plain version of the site. So we'll need to address that. But the big deal is what happens if we access HTTPS fleetmanchesterwood.io. Yeah, well, that's not good. I'm getting a HTTP 400 back here saying the plain HTTP request was sent to a HTTPS port, which doesn't seem to make sense. And in fact, really, we've got here everything the wrong way around. We really want this one to be giving an error and this one to be giving and this one to be working correctly. Now, I think the answer will be found if we edit the service L4 file. It's all to do really with this port configuration here. But what's happening is we're making a request to the load balancer on port 443, in other words, the TLS or SSL port. But remember, we are terminating TLS and SSL here. In other words, the certificate is in here, and all of the traffic is going to be unencrypted here at this level before it gets forwarded on. And I think all that's happening is it's being forwarded on at present to port 443 here on the Ingress controller, but it's actually being forwarded as a plain HTTP request. So actually it's the Ingress controller that's saying, why are you sending me a plain HTTP request on port 443? That's not right. And we can fix that quite easily. I'm back here in the service definition, and it's all to do with this port mapping here. We just need to do a little bit of rewiring. We'll worry about the plain HTTP port in a minute, but it's all here. HTTPS, which is coming in on port 443, the target port is also set. This label here just makes it 443 as well. And actually we don't want that. And as I say, that's because we're terminating this earlier than this configuration thinks. And it's just a case of the target port needs to be set to port 80. So that's going to send it as plain HTTP to the Ingress controller. For most circumstances, this is not a security problem. This link here is going to be plain unencrypted HTTP, but that's okay. It's inside our cluster. So only if you're on a really security paranoid project will that be a problem. This is just an inherent feature of terminating at the load balancer. If your project won't accept that, then you are going to have to look at configuring the Ingress controller or indeed the individual services with their own certificates. So that's complex management would be required there. I'm going for an easier but nonetheless secure approach. So that configuration is just changing this to forward to port 80 on the Ingress controller. Hope I explained that reasonably okay. So we've changed target port to 80 there. If we write that file and apply the changes, we'll repeat the earlier demo. Now I think if we do a curl on HTTP on the plain fleetman.chesterwood.io, I don't think we're going to see any changes there. Yes, that's still an error. We don't want that. We want to redirect to the secure version. So we'll worry about that in a minute. But if we go to https:// fleetman chesterwood.io, then wonderful. We are getting back the proper HTML for that site. So there was no complaining about the certificate being invalid. The real acid test of that now, of course, is to visit it in a browser. So https fleetman.chesterwood.io. And at first, this is going to look disappointing. I'm just getting back a blank page. But actually, this is just an error with my app. If I do a right click and do view page source, hey, it worked. We actually do have the HTML being returned. And all that's happening here is if I do an inspect and then click on console, it's my bad really. And you have to recognize that when I built this Fleetman app, it was only really designed as a quick and dirty microservice system for the training course. I didn't really think about all these things that I'd be doing with it over the course of a few years. It's just that to do the WebSocket connections, which is how this app gets its data, it's currently internally, and I hard-coded it in, so this really is bad programming on my part. I've hard-coded in a call to this URL here, which is ws : and then some URL. That's an insecure version of WebSockets. And the browser is quite correctly saying, oi, I'm not going to do an insecure request under the hood when you think you've got a secure connection to the site. So it's the JavaScript is failing. I really should have coded that better so that it knew which version to call. The thing we really want to be celebrating here is, can you see we do have a padlock? There's no errors being displayed. And if I click on the certificate, I can see that this is a certificate issued to this domain by Amazon, and it's valid for me for, it looks like about a year and 1 month. So this is looking great. We just need to fix the app problem really, and I'm sure there's an elegant way of doing this in Angular, but I'm not really an Angular programmer and I don't have time to work it out. So all I did off camera was I've created a new version of the web app image called I've tagged it with secure WSS, and I just changed the WS to WSS. Not the best fix in the world, but it will work for this demo. So to get that change, you would need to edit I think we've got it in a file called workloads.yaml. And if you find the deployment for the web app, the current image used is tagged release 2. I'm just going to change that tag to secure WSS and then apply that workloads. I'll just check that pod has started, and it has. And be sure here to do a hard refresh. So a control or command refresh here should now wonderfully, that's working absolutely fine. So yeah, now the WebSockets are going securely as well. So we're 90% there, but we've still got the other 90% to do, which is what happens if we visit the plain HTTP version. Now, as I say, big trap to watch out for here. Don't think, right, we'll test this. We'll do HTTP / blah, 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 hit return. Fantastic. It's redirected and it's working. We can go home and go and celebrate. No, you can't. Because I think the browser did that, and that had nothing to do with our load balancer. Well, let's verify that. A curl of HTTP / fleetman.chesterwood.io. Wow. Bad news. Yeah, it is returning actual site. Now, what we want here is a redirect to HTTPS. I realise I can test this on the browser. I've not visited q.chesterwood.io so far. And yeah, this is just giving us the not secure version. So this is really bad. And I can promise you that's what would have happened here had I not already visited the HTTPS version. So this is really bad. We need to fix this. This is the point where I'm going to struggle a little bit, because when I've had to do this on projects, I've had real problems getting this working. And it's just one of those things where I've ended up like hitting my head against a brick wall for several days, going through endless issue reports on their GitHub page. So for example, something that often happened to me was a 308 redirect loop. So I'd sort of almost get everything working, but I'd get infinite loops on some of the redirects. And so I'm really just showing you this issue report as an example of the kinds of problems I had. So what I'm about to present to you is really just the recipe that is working for me on my production projects. It's working at the time of recording, which is May 2019. I wouldn't be surprised if with newer versions of the Ingress controller, the method I'm using here might well break. This will feel like a little bit of a hack really, but I'm just showing you a Stack Overflow post to show you that this isn't something that I've made up myself really. So a similar kind of problem here, but if I go further down, there is a link you can follow there to a GitHub issue. But what they're showing us here is we can set up a little configuration which really just reconfiguring the Nginx server inside the Ingress controller. And we're going to do a little trick whereby any HTTP traffic we send to port 8080, which is just an arbitrary port really, but we send it to port 8080 on the Ingress controller. And we listen to port 8080, and if we receive anything on port 8080, we return a 301, and that will achieve the redirecting that we want. So we're really just extending the Ingress controller. As I say, this might not be necessary to do in the future, but certainly at the time of recording, I found it necessary. And we're going to be putting this configuration into the file that was supplied for us when we installed the Ingress controller, and that's this one, patch config map l4.yaml. Don't think we've touched that one so far. And yeah, the idea is in this data field, we can put key value pairs that we get from the reference manual. So it will be tedious to type in this. So I've created a GitHub gist so you can copy and paste this. I've also created a shortened version of that URL so you can find it at the URL you can see here. And just to recap what we're doing, really we should be able to use this force SSL redirect command set to true. Should have probably done this for us. I think it's partly the presence of the WebSocket stuff in this app that's causing the problem. With these extra lines, we're going to make the Ingress controller listen to port 8080. Defined that anywhere, but I'll come back to it in a second. But if we do get a request on port 8080, then we will issue a redirect to the proper HTTPS version. So if you can take a copy of those 8 lines, and then in your patch config map l4.yaml, we're just going to be adding those lines to the end of that file, and then save the changes. What's that port 8080 doing? Well, if we go into the service YAML, well, I hope this is going to be the last change we make in this video. Just going to do one more little crafty piece of wiring. So the idea is now, if we get raw HTTP traffic on port 80 of the load balancer, then we're going to forward this and make the change here to this new port 8080, which we've set up in the Ingress controller. That's listening on 8080 and will issue a redirect. And it will redirect to HTTPS, which will then be forwarded on as we had before. So that, I think, is the last change we need. Let's do a kubectl apply -f on the dot. So we've made a few changes there, and I don't really think we need to wait very long. Let's start with a test of what was working previously, the HTTPS version, fleetman.chesterword.io. Great, that's returning the website as it should. But now for the big test. We have a user who wants to browse the raw, unprotected version, HTTP version. Hold your breath. Fantastic. We have a 301 moved permanently. It probably should be a 308 these days, but 301 will certainly do just fine. I can't really test that here on the browser because that will happen automatically because I've already visited that page. But I haven't visited the secure version of q.chesterwood.io. So a simple refresh here, we want to see a redirect. And we do. And it's also repeating the authentication challenge. So let's log in and everything's looking great. We are on the secure version. So this is great. I realised that was a little bit hacky, and I wonder if that's probably not going to be necessary in the future as new versions of the Ingress controller comes out. But I wanted to show it you. That's something that I'm using on some production projects. The key thing is we have now got a secure HTTPS version of the site, and we have not had to manage the certificates, which is great. Remember that we are getting this easy management because we're terminating here on the load balancer. If you have some regulatory requirements that you've got to terminate deeper in the cluster, then this might not be appropriate for you, but it certainly works on my projects.